Okay, guys, I'm going to try and make this one nice and quick this morning. Let's get our, oh, that's a pen. I want the laser. Here's the laser. Let's get our laser ready. So, today we are discussing how we can tell if two lines are parallel. Two lines that intersect another line, that is. So, two lines are, I guess, would be intersected by a transversal line, would be the technical term. So, here we've got lines AB, and it's being intersected by lines CD and EF. Now, how can we tell if these two lines are parallel? Well, these two lines will be parallel if they cross this line, if they intersect this line at the same angles. So let's check if they are in this case. So here we've got 110 degrees. If this is 110 degrees, what will these angles be here? Remember, we've got a straight line that's got been crossed here, so that they have to add up to 180 degrees. Yes. So what will go here or here? 70 degrees. 70 plus 180 is, sorry, 110 is 180. Yeah. And then this side, well, it's opposite this, and as we know from last week, the opposite angles will be equal. Also, it has to add up to 180 with this one. So let's just fill in these two angles here with their opposites. Cool. Now, EF, this angle here is 70 degrees, so this angle will be 110. And then we can fill in, oops, I didn't fill in them. And then if we needed to, we could fill in these as well. Now, as we can see, in this one, the intersecting angles are equal. So these two lines are parallel. Ding, parallel. And that's because they are crossing AB at the same angles, basically. Easy peasy. All right, now in this one, we've got AB again, we've got CD. This time EF is a slightly different direction, but we're still getting 70 and 100. Does that mean that these two are parallel? Well, no, it doesn't, because the corresponding angles, aka 110 degrees on this side and 70 degrees on this side, these are not equal. These have to be equal for them to be parallel. And indeed, I'm sure we would see these two lines crossing quite quickly over this way. So just make sure that the corresponding and alternate angles are lining up to being the same as the other one. Not just if you see a number that's similar, make sure that they're actually going in the same direction. So yes, these are not parallel at all. All right, this time we've got four lines. AB is again being chopped up by some other lines. So in this one we've got CD, and we know that C, well, there should really be a point here, but anyway, this angle at C is 105, 195 here, and 85 over here. So again, if we're going to try and find out if some of these are parallel, let's fill in the other angle and see if any of these pairs are the same. So this one's 105. The other angle on this side has to add up to 180, so that's going to be 75 degrees. Same on this side as it is on this side. Cool. And then that would be 75 as well, and that would be 105. Again, the opposite angles are equal. Okay, what about with 95 degrees here? The other angle is going to be 85. Good. And then we can fill in the opposites. And then over here, we've got 85. This will be 85. This will be 95. Good. So, are any of these lines parallel? Well, CD isn't going to be parallel to anything, but G, H, and EF they both have the same values, so they will be parallel. Yay! So this line is not parallel with anything, and these two lines are parallel because the angles that the lines meet, AB, are the same. What about this one? And again, we need to start filling in the other angles in these intersections. So we've got 88, because these add up to 180. This is going to be... Yep, so these add up and these add up. Now already we can see two of these have the same numbers. And when we fill in all of our numbers here, we can see these values we don't see in either of these. So this is not parallel, but in this one and this one, because the numbers are the same, because the angles are the same, they are parallel. Now we could do a similar thing with a triangle like this. Now these lines weren't actually supposed to start here. But if we had a triangle like this, we can see we've got one big triangle and one small triangle. And we can check, we can prove that these are parallel. How do we find the missing angle in a triangle? We know that this is 45 degrees and this is 65 degrees. If we want to find this angle, we do 180. Let's get my pen out. Okay, so yeah, so it's going to be, because we've got the three angles here, it would be 180. Oh, so messy. It's difficult doing this with a mouse, I promise. So that's going to be 180 degrees minus 65 plus 45, okay, which is going to give us 70 degrees. So the value for this one is going to be 70 degrees. Now, if you notice here, STU is also 45 degrees, which is actually what tells us that these two lines are parallel. And TSU is 65 degrees. So if we want to find out this angle, well, we already know it's 70 really, but if we wanted to double check, we would do this same sum, dearie me, 180 degrees minus 45 plus 65 degrees. So this one's going to be 70 degrees also. So we can tell that these two lines are indeed parallel. Okay, one last question. Now this one actually comes directly from the workbook. So this is a freebie, really. But so in this case here, we've got another set of three lines. Oh, where's my pointer gone? Hello. Oh, here we are. Sorry. Don't know what happened there. Yes, so we've got AF. Oh, well, AC is up here. DF is down here. And in this one, we know that the angle over here is 55 degrees. And in B, this is 125 degrees. So what will this be here? Remember, this is a straight line, so it would be 180 degrees minus 125 degrees, so that's going to be 55 degrees. Perfect. And down here, this is going to be 125 degrees. Now, this is something we've not really covered, but, and that's why I'm covering it in here. When you take the side of a quadrilateral shape like this, the total of these two angles has to add up to 180. Which isn't something we really cover in well, in this unit. But yes, so, oh, come on, computer. Okay, well, I'm stuck with the eraser, so that's going to be 125 degrees. And again, if this is 125 degrees here, then this has to be 55 here. Now, can you see if any of these lines are parallel? Well, down the bottom here, FD, that's definitely not going to be parallel to anything. But AB, that meets at 55 degrees, and BE also meet at 55. Sorry, that was AF. Did I say A? Anyway. So we can see that there are two parallel lines. Is CD parallel to anything? No, not really. It's just these two lines here. Anyway, that was a quick run through of that. Now, if you fill in the work on the workbook there, I'm going to be available to chat to as well. And if you've got any problems, please shout it out, okay?